Happy Easter, everybody. We have a special guest today. When my kids were young, we would travel across the country quite a bit to go visit with family. And one of the things that we did in the car was we would play with a puppet that we would check out from the Orange City Library. And this puppet had a name, a very clever name of Dog. And as you can see, I've got a puppet here. We recently dug Dog up from the basement. Yeah, I know, Dog. You've been in the basement for 5 or 6 years. That's a long time. But Dog has been in the basement for 5 or 6 years and recently came out, partly because of the coronavirus craziness, partly because, well, who knows? Who knows why Dog came out? But Dog's going to help us do some chemistry problems. Mostly he's just going to kind of hang out here with me and have some fun. So let's see if we can learn some chemistry about balancing redox reactions. All right, you game, Dog? Dog says yeah. Okay, so here we go. All right, so when we're balancing redox reactions, we're always going to be thinking about the type of solution that it's in. And the first thing I want to do is think about balancing a redox reaction in an acidic solution. Okay. Now there's a stepwise pattern to this. There's kind of an algorithm that we can use, and that algorithm takes us through balancing these things according to what's called the half reaction method. Got that, Dog? Half reaction method.
Yeah, half reaction.
Okay. So first thing is we want to split everything into our half reactions. So I've got an example over here of dichromate with oxalate. And we're going to split this into the chromium part, and we'll have the oxalate part, or the carbon part. That's not water, that's CO2. I'm sorry about that. Did you write that? Must have. So we're going to have Cr2O7, 2 minus, going to Cr3 plus. That's one of our half reactions. And we'll have C2O4, 2 minus, going to CO2. That's our other half reaction. Okay, next step. Dog's going to help us here. We want to balance everything that is not oxygen and hydrogen. Got it, Dog?
Yeah.
Okay. So that means that we need to put a 2 in front of the chromate, or the chromium, and a 2 in front of the CO2. Okay, so we're done with that step.
All right. Okay, good.
Let's try next step, balancing oxygen by adding waters. Okay, so we're gonna add waters to balance out the oxygen. In this half reaction, we have 7 oxygens on the left, and so we need 7 oxygens on the right. So we're going to put 7 waters over here. Dog, what are you doing? Uh-oh. Okay, did you guys get that? 7 waters on the right. Our C2O4 equation is already balanced with regard to oxygens. Next step, we want to balance the hydrogen by adding H+. So in this first one, we need to add 14H+. Balance charge by adding electrons wherever they're needed. So if we add up the electrons in this reaction, we have a -2 charge over here, and we have a 0 charge. So we need to add 2 electrons over here. Got it? Okay. All right. On the top one, this one's harder. So we have to add up all the charges over here, and we get +12. Right, Dog?
Yeah.
And over here, we've got +6. So we need to add 6 electrons to this to make them both +6. Okay. So 6 electrons are gained by the dichromate. 2 electrons are lost by the oxalate. So that means we have to multiply this half reaction by 3 in order to make sure that the number of electrons gained is equal to the total number of electrons lost. Then on to step 7, we can combine the half reactions, and when we do that we get 14H plus Cr2O7 2 minus plus 3 C2O4 2 minuses, giving us 2 Cr3 plus 6 CO2, and that's it. And then we can check to make sure that our charges and our atoms are all balanced. So let's go ahead and try that. So we have 14 hydrogens. Oh, I forgot my waters. 14 hydrogens on one side, 14 on the other, 2 chromiums, 7 oxygens plus 12 more gives us 19. And we have 12 plus 7 giving us 19. So that's good. And carbons, we have 2 and 6 and 6. And the overall charges should match up as well. So that's it for balancing a redox reaction in an acidic solution. Say goodbye, dog.
Bye-bye.